Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this video, we'll be covering solutions and molarity. Let's get started. So if you all recall in previous chapters, we talked about this idea of actually combining multiple pure substances together to make different mixtures. And one of the type of mixtures we talked about were these homogeneous mixtures. And we learned back in chapter 1 that the word homogeneous meant that it's well blended all the way throughout. And so that word homogeneous is interchangeable for what we describe as solutions. So solutions are those things that have some material that's been dissolved in them. That typically is what's called the solute. And it's dissolved into an environment that is known as the solvent. And the combination of the two makes what we call solutions. And so this is what happens when we take some salt and put it in water and allow it to dissolve. That water now represents a solution of sodium chloride in that water, or aqueous solution of sodium chloride. And so for most purposes in this class, your solvent, the thing that we're going to be dissolving most things in, is going to be water. Water is considered to be your universal solvent. And then the things that are being dissolved into it would represent our solutes. So remember, solute plus solution, remember, solute plus solvent equals solution. Now, when we're describing the solution, we want to be able to define how much of that solute was placed into the solvent environment and what is that now composition that's been created. And so when we're describing it, oftentimes we will describe it in a qualitative manner, meaning that we describe, is there a lot of the solute or a small amount of solute present? Or we're going to learn in a little bit how to do it in a quantitative manner. And so we want to be able to accurately describe how much each of the components are found in this compound or in this solution. So when we're looking at it from qualitative terms, the way we describe solutions is by saying that they're either dilute, meaning there's a small amount of solute compared to the solvent, or if they're concentrated, meaning there's a larger amount of solute compared to the solvent. A great way to think of this is if you've ever made any type of like iced tea or any type of drink where you're adding sugar. If you put just like one little scoop of sugar in, that's going to be a dilute solution. But if you put a lot of sugar in there, that's where you'll have a more concentrated solution. Now, while qualitative terms are great, it really doesn't help us to accurately figure out how much of each substance is present. And so that's where the quantitative measure will come to. And so a more precise way of describing solutions is by actually quantifying the amount of solute that's present in a given solution environment. And so what we're going to be doing is determining what is called the concentration of the solute found in a given amount of solution. So how we quantitatively define this in chemistry is through a concept known as molarity. And if you look at that word, you guessed it, moles are involved. And so the molarity is looking at the ratio of the moles of the solute compared to liters of the solution. So go ahead and put a star by this equation because we're gonna be using it a lot. And if you like that triangle thing that I showed you with density, it works here too. So you could say that your molarity, capital M, is equal to the moles of something divided by the volume. Very important to remember when we're solving this that volume of solution has to be in liters. And then again, that top value is the actual mole amount that's present. So the molarity that we're going to be calculating, when we define its units, will have the symbol of capital M. So when we're asked to prepare a solution, what does that physically mean? A 1 molar solution of NaCl, for example. Well, what that would mean is that I have 1 mole of NaCl for every 1 liter of solution. That's what that 1 molar physically means. Well, how do I go into a lab and measure a mole? Well, what we can measure is not necessarily the mole, but what the equivalent gram amount would be of that mole. And so if you know the moles, we would convert that to the gram amount and then dilute it in the appropriate amount of water to create that total volume of solution. And so in this case, if we have 1 mole of NaCl, that's equivalent to its molar mass of 58.44 grams of the material that would be needed. So we would weigh that out and then transfer it into a flask, preferably a volumetric flask, which will allow us for accurately measuring out the actual volume. We then are going to add enough water into the flask to first just dissolve whatever solute we're putting in there. And then we're going to add enough water up to the mark that corresponds with the 1 liter volume. And then invert it a few times, make sure it's well blended, and we now have a 1 molar solution. And so this type of calculation is one of those ones that you'll use frequently throughout your career if you were to go down a chemistry path. So let's try a few examples. It says find the molarity of a solution that has 25.5 grams of KBr, potassium bromide, dissolved in 1.75 liters of solution. So just to remind ourselves, the formula for molarity is the moles divided by the volume of the solution. And so we can see we have some information provided for us. We know the volume of the solution, and it's in proper units of liters. But all we know about the solute is the mass of it. And so what we would want to do to solve this problem is to first convert that mass to moles, and then we can plug it into our equation. So if we take our 25.5 grams of KBr, first step is to calculate the molar mass. So that would be 39.0983 plus bromine, which is 79.904. And that would give us 119.0023 grams on the bottom. And on the top, we would go to moles. And we plug that in. We end up with 0.214 ... moles of KBr. Then if we want to calculate the molarity, we now plug that in. The molarity equals your moles, 0.214 moles, divided by your volume of 1.75 liters. And that gets us 0.122. And our units here would be capital M for molarity, or technically you could also say moles per liter, since we didn't cancel anything out. Next problem, what is the molarity of a solution containing 3.4 grams of ammonia in 200 milliliters of solution? So again, we see that we're given gram amount about the solute. We also notice that we're given information about the solution volume, but you should notice that we don't have the proper units. We need this to be in liters. And so if we quickly convert, you could set up the conversion factor, or you can move that decimal point 3 places as such to represent our volume in liters. We know for the molarity formula, we first would have to convert our grams, 3.4 grams of NH3, and we would want to get that to moles of NH3. Grams of NH3 on the bottom. They've given us the molar mass in this case, so just go ahead and take that as is, 1 on the top. So 3.4 divided by 17.03, and that gets us 0.1996. So really we can round that up for 2 sig figs, 0.20 moles. And then we take our 0.20 moles and divide it by our volume in liters, so 0.200, and that would give us 1.0 molar as the molarity for this solution. Okay. Good. Next problem. This one says, how many liters of 0.125 molar NaOH contains 0.5255 moles of NaOH? So now in this case, we're solving for the volume. It's asking for liters. So again, look at that triangle thing. If you don't really like rearranging equations, this could help you. So again, you cover up the one you're solving for, and that will give you your equation. So if we cover that up, the volume equals the moles divided by the molarity. And so if we plug that in, we have 0.255 moles of NaOH on the top, divided by 0.125 molarity. And what we end up with is 2.04. And what would the units here be? Well, they would be liters. Because remember, molarity is really moles per liter. And our moles have canceled. We're dividing by liters, inverse liters, and so that would become liters on the top, okay? Last one says, determine the mass of calcium chloride in 1.75 liters of 1.50 molar solution. So if we're determining the mass, that means we ultimately want to get grams. But given the information that we know, we have a molarity, we have a liters. The first thing we'll be able to solve, just like before, is the moles. And then once we have the moles, we can get to the grams. Going back to our triangle, molarity, moles, and volume. Now we're going to cover up the moles to get our equation. So moles equals molarity times, and that should be capital M, times volume. So that would be equal to 1.50 molarity times 1.75 liters. Again, making sure that volume's in liters. And so that would give us 1.5 times 1.75, and we get 2.63. And then this would be moles of the solute, the thing that was dissolved, the calcium chloride. And again, the reason we're getting moles is because molarity is moles over liter. So those cancel. And then from our mole amount, 2.63 moles of calcium chloride, we can now get our mass by using the molar mass. So 1 mole on the bottom of calcium chloride and 110.98 grams of calcium chloride on the top. Okay, and then we plug that all in. So that times 110.98. And what we end up with is 291.8 with 3 sig figs, 292 grams of calcium chloride would be present. I hope this information helped you to understand molarity and how to calculate it. Be sure to like, comment, and subscribe, and let me know what other content you would like to see. I'll see you guys in some more videos later. Have a great day. Talk to you soon. Bye-bye.